thanks for the opportunity given to me to share my working experience in National of Ocean Technology with you, that too to the agricultural field, because agriculture plays a major role in all over the engineering field. I don't know why you have taken that agricultural field, but let me try to hear from you why you have taken this agricultural field. You are from agricultural engineering, am I right? Okay, because Madam told that it should be an interactive section. So why you choose this field? Then, because agriculture was the past, and agriculture is the present, and agriculture is the future. So our land is the agriculture. Once upon a time, one man asked Sardar Vallabhbhai Patel, and what is your culture? And he told, our culture is agriculture. So there we place a major role. So one of the major issues that we are facing from the government of India is there are 5 major issues. One thing is population, you may be rightly knowing. Another thing is food, and another thing is environment, and another thing is water, and another thing is environment also, and as well as water. So most probably, if you see, food, water, and the environment plays a major role. So these 3 need to go hand in hand. We cannot separate it. So these play a major role, and in all these fields, the agriculture plays a major role in sorting out those issues, that is the food, environment, and as well as the water. Even though the earth's surface is surrounded with 70% of the water, still we are having a scarcity of the water. In one side we are having a large amount of water, other side there is a scarcity. In order to have a very balanced conditions, we need to have a good environment also. So in this way, that is average requirement presently required. So all the water flowing in the rivers are all used by the farmers. So why we need to take the engineering? I am not asking you to go to the field and need to work in the field and in the land, but I expect you to take up the technology, take up the solutions for the farmers in order to have a easy life for the farmers. Because the innovative with the product ideas to bring into a product is a complex and difficult subjects. Because it has to work in a different environment, it has to function in a easy for the farmers who is an uneducated, but he is feeding us the food. So you can see, once upon a time you may, but daily you need to think about the farmers. But when we are eating food, we need to think about the farmers. But the only thing is, he is serving us food, but he is dying without food. So that is the sad and thing about us. So what do you know about what is innovations? Ideas means any solutions, intelligence and idea, and inspiration, creativity, visions. So in order to have the innovations, all may be having innovations. So when is such innovation will come to you? Pardon? When you face problems, yeah. Because when you face problems, you need to come out of those problems, you need to find a solution for the problems. So necessity comes from the innovation. If there is no necessity, whether we need to go for an innovation, I don't think it's so. So innovation and the necessity plays a major role for the innovation. So then you need to find out a solution for it. So you may be saying this, there are large amount of innovators. For example, Edison is the number one famous for the invention of the electric bulb. Almost he tried many times, but after all kind of things, he struggled a lot and implemented the electric bulb. So the thing is Nikola Tesla. You may be knowing Nikola Tesla, which is applying to the homes and the buildings. So this thing is Benjamin Franklin. He drafted almost all kind of drafting for the independence of the Americans from the free from the Britain. So he drafted the Britain from the American constitutions also. So that is the Graham Bell telephone. Then Fleming, Alexander Fleming. You know penicillin? Which saved many deaths from the infection. So Mary Curie. Yeah, rhodium and polonium, which is used to treat the cancers. She is a woman or men? Woman. She is the first woman who got the Nobel Prizes, and she is a physics and chemist who got the Nobel Prize for the two scientific engineering fields. She is a physics and as well as chemist. Then Wright brothers? No, right. Then Galileo? Okay. These are all the famous innovators which I find it very passion because they are all from the different fields. So these have come, they face a large amount of problems and often finally they succeeded. What is the passions? Why do you want to do innovations? So necessity is the mother of innovations. Without necessity we cannot come. And the passions creates motivation which leads to innovations. So what is a passions? Passions when it comes when you form your grow and afterwards it goes to it which leads to the innovations. Otherwise innovation is impossible without the passions. So we need to have a large amount of passions without which that innovation is possible. What are the various forms of types of innovation technology? So you can see the incremental innovation, disruptive innovations and architectural innovation and radial innovation. When you see the technology, that is the existing technology and as well as the new technology that you are forming, it should go to the finally it should go to the market. It should suit the market. So in the market there is existing and new. So what is the incremental innovation? When you find an add-on value in each innovation, when you add an add-on value, small increment, that comes under the incremental innovation. And next thing is the disruptive innovations. That means when you finding a solution for the problem, which will ultimately reduce the cost of the component, it comes in a disruptive innovation. Then next thing is the architectural innovation. What it means is both the technologies are same. The technologies are same, the basic fundamental concepts are same, but it is used for different applications. But it should give to the different persons who have not used the concept. For example, architectural innovation means there are many architectural who can construct buildings in different sizes, shapes and different methodology they adopted. So that comes in the architectural innovation. What is the radical innovation? That is new technology finding a place in the new market. So the technology is new, which forms a disruptive or causes a very new technology which has the value large amount. For example, iPhone. Previously they are used the button phone, when is the iPhone which takes a disruptive in the market and finds a value. For example, for the agricultural engineering field, farm management with the sense of technology. For example, I forms here added value and it can be sent to the market and it should be added the value to the farmers for the easy applications. So these are the different types of. And what are the factors for the innovative index? What are the factors that we need to see for the innovative index? Where is India lies and where is our state lies when compared to the other states in India? So these are all some of the factors that innovative index find out. So one thing is the trademark listed, then second thing is the patent activity, then the researchers intensity, scientific journals, and how much what are the amount of journals that we are publishing here to form the innovative index, and high-tech exports. Previously, I heard that we have exported large amount of seeds to the Japan, but nowadays we are finding it very difficult to export even 1 ton of fertilizer, 1 ton of India in the 48th position. So the overall innovative index comes under the knowledge and technical outputs, then business sophistications and market sophistication, infrastructure, and human capital and research, and institution and creative outputs. You can see this global ranking, and we can see place Switzerland takes almost first rank in the knowledge outputs and as well as the overall ranking, and then Sweden. So this is the statistics of the developing countries like India. You can see India place which state, and the factors on country researchers are million. You can see the number of journals and publications, how much, and the patent filed 45,000 when compared to China and France. So what is innovations in agriculture? So that we have seen the innovation in different fields. So in different fields, you can see the artificial intelligence and robotics and international IoT are forming a large amount of technology development in almost in all sectors. But if you see innovations in agriculture are primarily concerned with the need of increasing the production. The agricultural innovations means we need to increase the production, we need to increase the quality of the product that we can give to the market, and the production process precision is seed and spray technology can also reduce the pesticides by nearly 90%. So these are the latest technologies that is available for innovation that we need to develop in the agricultural sector. So the countries of origin of the different solutions, now you can see nearly major portion goes to the France, that is the Europe countries, then it is Germany and Italy. So these are the countries of the origin of the Islamic Floxia Global Index. So what is the megatrends distribution in the agricultural innovations? What is the megatrends innovation? So during 2020, according to the Intercoma Connects event 2020, so they conducted an event in Barcelona, and out of 3,200 companies they have participated for the startup. Out of 3,200 companies they have selected nearly 300 startups, which shows the promising interest and as well as the closely following of the megatrends. And out of which they have selected the digitization, robots and Internet of Things and sustainability. So these are the major megatrends: digitization, robots and IoT and the sustainability. And they formed 9 groups where the SAS as the solution and yield monitoring and estimation, and the thing is the growth of farm management integrated platforms, the utilization of drones and the sensors, IoT in farming and smart agricultural machines. So in the innovation development, what is the innovation development that we need to go through is in the farming and smart agricultural machines and utilization of drones and sensors. So these are coming under the 9 trends that is going to see globally, where particularly these mega trends are growing one by one day, and during 2030 or almost 1 decade, there are crores of rupees going to spend, and we are going to earn on GDP for the India is also going to grow. So what is digitization? The technology industry is quickly reacting to this need of the digitization, and there are many startups focusing on solutions to improve the quality and the speed of the decisions undertaken. So that comes under the digitization. It is coming under a technological development. So these are the usually a software-based solutions and artificial intelligence and image recognition and data systems of the farmers. Then comes to the robots and the Internet of Things. So recent development innovation technologies are also agricultural machines where themselves take the decision, provide real-time and complex analysis. So these consider the robotics or the Internet of the Things, IoT things. Coming under the SAS solution. So this is the yield monitoring and the estimations. To how much is a coconut that is formed and the fruits is depending upon the size of the thing, and it is difficult for the farmers to count. It is a boring job. For in order to avoid that, we can take the power of imaginary is getting the importance of the precision engineering. So this kind of forecasted average size, and it goes by taking the picture of the fruits with a smartphone. By this one, we can also increase the yield a large amount of things. This is the growth of the farm management integrated platforms. So this plays a major role when compared the data sources involved in the loss of a tracking system. So to solve this painful point, many companies are offering the integrated platform to provide a decision making with a unique solution, so that the farmers or solutions can take a very quick decisions, and they give us the decision making as a faster thing. So this is the growth of the farm management. Then utilization of drones and sensors management. These are the autonomous vehicles, and they are able to take pictures of video and the flying over fields and orchards without moving the farmer from their houses itself. They can control and monitor. So this is the IoT in farming. So this is more in the direction of the pest monitoring. Able to packaging material from the industrial and agricultural waste. Also we need to use recycled material, so to produce the packaging material. With this one we can reduce the minimize of the wastages. This thing is the eco-friendly plant production. Very innovative and fancy solution, development of urine-based fertilizers and the use of the algae and the microorganisms to develop the crops and the plants. So these are the
economics, socio-economic conditions that is coming up in the market in form here, recent technologies. Next is the balancing of economic and environmental conditions. So whenever a company is putting up a plant or any other thing, somehow the environment is getting destroyed. For example, if we put up a plant or if a company is coming, translate into the lower cost and higher profit of the farmers. So we need to have a very balanced conditions. So next one is the water management. So this water management prompts to leverage sensors to automate the irrigation process and the decisions based on the soil. These are some of the mega trends that an innovative should do. Either it will come from a SOS software as a solution in the monitoring and estimation and the monitoring or smart development of the smart agricultural machines are those of the major trends in the agricultural innovation where we can find. Now we will see how your innovative ideas that can be bring up the product or the ideas of the product. So in NOT, we have developed various different products. Now up to this point, we have seen various where and you can form a solution for the innovative ideas. In NIoT, we have developed many innovative products where anyone in the organization can do it. Because we stand between the academic and the industries. Because we do not be in the academic and as well as the industries, but when we think we need to find the solution, we need to find the optimization for the efficiency and the effectiveness for the industry. So what is the energy of the freshwater? Just the offshore structure, this is the marine biotechnological and the ocean electronics instrument. These are some of the innovative products that we developed from the NIoT side. So now agricultural definitely requires a large amount of water. You agree with me? So even though water everywhere, but not using for the limited large amount of water. So this is the now I am telling you how we have developed an innovative technology for the generation of large amount of water. What is the existing technology? Why we need to go for an innovative technology in order to have a balanced conditions for the food, water and the environment without destroying the environment. How we have developed the innovative ideas into the product. So this is the unfortunate situation in many parts of India. This is the pictures taken from the Ramanathapuram district where our late Abdul Babu birthplace. So yes, the government of India and both Tamil Nadu is seriously fighting, committed to find a viable solution for the needs of the country. So where is the water requirements comes from? So during 2020 to 2008, our Chennai region, the water requirement is around 500 MLD, but in 2026 it's grown up to 2200 MLD. It includes but presently the water requirement is 1400, but presently we have around 900 MLD of water. Still there is a scarcity of the 400 MLD of water. This includes the water scarcity, this includes the established plant at Major and the ECR road, namely. So all put together, still there is a scarcity of the water. So what are the sources of drinking water? Some of the possible ways are minimizing the wastages of available water and recycling of used water. So even though the conservation of water can happen naturally by rainwater harvesting, over the past few years there has been. So with this introduction, we can very well say that desalination can be a solution for generation of larger volume of water in order to have a peaceful survival of mankind. For example, in Tutur Thermal Power Station, where the water is flowing in the Tamrabarani water, instead of the water, Supreme Court has given a clear direction that the water flowing in the river should be used for the domestic and as well as the agricultural purpose and not for the companies or any thermal power plant. So with this introduction, we can very well say that the desalination can be a generation for the larger amount of volumes to in order to produce a larger amount of volume of water. Now I am seeing, now I have, there is a problem that I have that there is a water scarcity. So now I need to go for a existing desalination technology. What are the existing desalination technologies in the market? So we can see the thermal distillation and the membrane and the, I have classified this process into a phase change process and the non-phase change process. In the phase change process, we can see the multi-phase flash evaporation, multi-effect distillation and vapor compression. In the non-phase change process, it comes under the reverse osmosis and electrodialysis. So you can see the percentage share of desalination process across the world. The seawater reverse osmosis plays nearly 53% of the total market share. And out of which, MSF takes nearly 25% of the market share. This I don't want to tell about the reverse osmosis. Here the water, when the pressure is applied to the concentrated side of the membrane, the purified water is comes to the presented impurity. So this is the high pressure, and it goes to high pressure pump and it goes to the membrane process. Here, a large amount of chemicals need to be added in order to make the treatment more efficient and the effectiveness. In order to increase the effectiveness of the pre-treatment and in order to increase the life of the membrane, we need to have a large amount of chemicals. So this is the major disadvantage in the reverse osmosis. So here, reverse osmosis means the microfiltration, ultrafiltration and nanofiltration and pumps. The last is the reverse osmosis plant. So I have classified about the four sizes that is available in this one. This comes to the thermal desalination. So here the same principle of evaporation and condensation is adopted in the thermal desalination. In almost thermal desalination, we record the steam from the power plant. Without steam, we cannot go for a thermal power plant. So what are the now? I have find out. I know what is the problem. What are the existing desalination technologies that is available in the market? Now I need to know what is the limitations that is available in the existing technology. Why should not we use it? Why should the government of India should not establish more amount of desalination plant in the existing desalination technologies of reverse osmosis or multi-stage flash evaporation? What are all the limitations that is existing on MSF and MBD? This multi-stage and multi-effect distillation requires large amount of steam from the power plant. When compared to countries like Kuwait, Arabia, and other oil production countries, where the steam is available at a cheaper cost or at a lesser cost. But we cannot use a steam because steam is not available at a steam is very expensive in the context of India. And to prevent this very expensive and hazardous chemicals are required to feed the seawater, and generation of maintenance of vacuum and the problems of scaling are the major technological challenges, and RO has its own limitations such as chemicals are need to be added and finally dumped into the sea. Finally, what is the environmental issues? Environmental issues are higher temperatures of the power plant and the desalination presence of the biocide and chlorine and acid chemicals used to produce the surface water and the DM water. So these are all the limitations that is available in the existing technology. Now NIOT, upon the innovative, found out a new idea of making the process called low temperature thermal desalination. So what are the limitations in the existing technologies? What are the environmental problems that is available in the existing technology? Now we have found out here an innovative idea to form here to generation of large amount of water. What is the low temperature thermal desalination? So we know that water boils at 100 degrees centigrade. So the water boil at 100 degrees centigrade, we require a high amount of energy. But water can start also boil at room temperature itself, provided the pressure is very less. So here we are heating the water at a low pressure. We are heating the water at a low pressure, not at a 100 degree. In the existing desalination technologies, they are heating up the water because they record a large amount of energy to heat up the water. Here we are reducing the pressure at a room temperature. For example, the room temperature is around 28 to 30 degrees centigrade, where the saturation pressure is around 30 millibar. So if we reduce the pressure to 25 millibar, we can heat up the water. So that is the decreasing the system pressure by reducing the boiling point of the water. So this is the presently adopted desalination process. So this is the schematic and how we have developed the different kind of components that are shown in the slide. So here we are consists of a flash evaporator and the condenser. Very simple desalination method that we are adopted here. So here the water from the surface sea water goes to the flash evaporator. Flash evaporator means that water starts boiling at the room temperature itself because of the low pressure. Due to that, some amount of vapor is generated. That vapor goes to the condenser here. This condenser is the existing component. This comes under the disruptive innovation technologies. And conduction is the existing component. Flashover is also existing component. But only thing, we are shooting up to the ideas that is formed due to this low temperature thermal desalination product water can be generated. So this is the process. First, after developing the concept, now we have to go to the experiments to read out whether it will work in the actual site of timing addition. So this is the water desalination laboratory in NMD campus, and you can see the process component, the flash evaporator and the condenser and the vacuum pump, the flash evaporator and the condenser and the vacuum pump and the freshwater tank. So these are some of the experimental plant that we generated, and we have conducted a series of experiments to find out what is the temperature difference, what is the temperature that is required, what is the optimum pressure conditions, and what is the optimum temperature that we can increase the yield. Otherwise, in order to have a very large temperature difference, getting a small amount of water is very difficult, and it is very difficult to do the experimental studies in the actual plant. So these are some of the test facilities. You can see the 3D process component. Upon developing and taking a large amount of data and analyze it, we established the desalination plant in almost all islands. You can see the Kavarachi plant in 2005 and 2009 Minikai and the Akati Island and Amni and the Kanpani. So these are the few desalination plants that we established. As an NIOT, we are working doing the R&D activities, and we are not interested to establish the plant. This we will give it to the industry to establish. Then only they can give us the feedback where we want to do the optimization and where we need to concentration in order to reduce the cost. Here you can see the bridge is there. Bridge need to be constructed to suck the water from the deep sea. The deep sea of around 1,000-meter water depth. That water is very rich in nutrients, and it will be used for aquaculture also. So these kind of plants we have established. Right now, and now also we are not stopping. We are now developing our ideas in radiant technologies, radiant innovative technologies. Now, there what we are doing is here the power need to be taken from the grid. Here the power need to be taken from the grid to power the desalination, to drive the desalination plant. In order to make a self-sustained desalination plant, what is we are doing is from the flash evaporator going to the condenser mode, where we are making a turbine. So in order to make a self-sustained desalination plant, so you can see the seawater, there is a lot amount of construction need to be there, because we need to have a sump at the water depth in order to pump the water from the deep sea. So there, in order to from flash evaporator condenser, we are developing a turbine, which is also the existing component that comes under the architectural innovation. So we are developing a turbine there, so that it is a self-sustained desalination plant. So the plant will be need not to take the power from the grid, so that operational expenses also can be reduced. Here the main motto is the plant need to be an independent. For the islands, you cannot take the water plant. Previously, they have used a large amount of RO plants and the thermal desalination plant also, but none of the plant is sustaining here. Why? Because is that they need to take a large amount of things and need to be operated, and it is very difficult. For that one, they are not to be able to do it. To their environment, we are due to use a easy environment and easy to be able to operate. That is to be a simple technology. So with this one, we have developed a fire operator and the condenser, and in between that, we have put a turbine. So this is the closed cycle. So this is the process of the open cycle. With this one, we are developing a open cycle turbine for the turbine, and now we are using the power module component that we are developing the CFD studies, and a large amount of CFD studies were taken in order to generate a large amount of power. Because in order to produce a 1 lakh liter per day, the power generation record is 45 kilowatts. 45 kilowatts because of the warm water pump, cold water pump, and the vacuum system. Now, in order to make it a self-sustained desalination plant, we need to generate the power from its plant itself by condensing some amount of vapor before the flash evaporator vapor goes to the condenser. We need to generate some amount of water. For that one, we are developing a condenser. This is the 3D view of the water-powered desalination plant at island. So this is the first ever in the plant in the world. It consists of the flash evaporator, turbine, and the condenser. Now you can see the what are the limitations of existing technology. What is the technology that will be very useful for our island conditions and the mainland conditions and the process power plant. And we have developed, designed a large amount of components of flash evaporator and the condenser. island. So this is the low temperature water powered desalination plant at our beach. So this comes to the this is up to the island conditions. So we need to develop a technology. If we need to find out a solution, what is available in their place. For example, you can take up a student, one from the abroad and one from the Indian conditions. You are developing some seeds and you are finding out a solution for the farmers. They are also finding out the solution. But we need to see the environment that is available in that condition and environment is available. Some of the, for example, arid condition where the product that is developed need to distance from the dirt and the or otherwise the Arctic conditions in order to remove very high temperature. The product that is developed in order to withstand a high temperature or the cold climate or freezing temperature. So the product that is developed for the island cannot be used for the mainland conditions. Mainland conditions cannot be used for the island conditions also. So this is the large motor desalination plant. All the plant components that we have installed there, because all the plant components that we have installed in the platform and it is moved to the water depth, where we have the single point mooring is selected at 1000 meter water depth so that it can be self-sustained desalination plant. So this is the self-sustained desalination plant of the plant. And upon seeing the 1 ml plant, now we are moving in the step of it is a self-sustained desalination plant again. So the experimental and numerical studies of the offshore platform such as of the platform mooring and all completed, and we are now going to establish the plant. Now, how to develop the technology that we have developed the technology, how to use it for different applications. That comes under the architectural innovations. Because in architectural innovations, the product or components developed is same, but we are using it for different applications. So far, this technology we are using for the island application and for the mainland. But in almost all the process power plant also it will be adopted this technology, because large amount of chemicals, large amount of power plant uses a large amount of seawater, and it also requires fresh water. It also requires large amount of fresh water to cool the engines. In order to become a thermally balanced condition, they require a large amount of water because the water needs to be pumped to the boilers. So they are pumping a large amount of water to the boilers. In order to make up the makeup water, they are taking the water from the local sources or the rivers. So in order to stop them, how this technology can be used for the power plant. You can see this is the simplified layout of the process scheme. So the water taken from the downstream water goes to the condenser in order to make it a thermally balanced condition and goes to the cooling towers and goes to the cooling towers. From that cooling towers it again go to the sea. So now the developed technology, if we place instead of the rays from the water goes to the heat the water and goes and when the distillate is formed because of the solar radiation. So this is the simple technology. This technology we can generate some amount of 4 liters of water daily in a 1 meter square area. So upon doing this one, we also developed a solar powered desalination at a larger capacity of 6 meter cube per hour in the Ramanathapuram district. It consists of 2 stages. One thing is the solar fields and another thing is the MSF and multi-effect desalination. In the solar fields, which consists of 600 meters cube, it consists of a linear Fresnel reflector collector where it receives the sunlight and it transmits to the receiver, and using the receiver the steam is generated. That steam is used for our replacing the vacuum system. Replacing the vacuum system in order to create a low pressure in the flash evaporator, which is used to increase the yield. So this is the sum of amount of innovations and these ideas that is developed and incorporated in the system, and we have seen a large amount of improvement in terms of the efficiency and the effectiveness of the heat exchangers. So this is the solar power desalination plant. So we can see we have established the Ramanathapuram district and the Kanyakumari project. So this is the some of the. Next comes to the wind energy. In order to have a plant at the island, we need to take the power from the wind. So this is the oscillating water tower principle. It is a simple breakwater system. The air flows through the turbine. This drives the electrical generator. Here raise causes the water to fall, rise and down. Here is a fixed water column. Here the waves causes the water column to rise and down, so that the compressed air goes to the turbine and it generates some amount of electricity. So this is considered here the 3 forms of kinetic energy will come. Here once the air compresses and releases, the air goes to the pneumatic energy, and and the pneumatic energy is converted into the mechanical energy, and then using the air turbine, and then the mechanical energy is converted into the electrical energy using the turbines. So this is the first ever wave power desalination plant. Here the plant is established in Brinjal near Trivandrum in India. And using this power, we also established a desalination plant, a sustainable generation plant of 10,000 liters per day. So this comes under the wave energy. Next comes to the hydrokinetic turbine. When we go for the Andaman and the Port Blair and Makassar strait, we can see a large amount of currents are produced in the, large amount of currents is there in the Andaman area. So using these currents that is available at 2 meters per second, we also developed some amount of hydrokinetic turbines and installed at 2 meters below the surface, where we generated some amount of power. This comes to the ocean current turbines. This is the ocean current turbine.